Yeah. Hello and welcome. Welcome to the Kitchener-Waterloo Video Tech Meetup, July 29th, 2025. Today we welcome Nicolás Levy. He's going to break down how to ensure thousands of viewers watch your live events at the same time. Nicolás has been working on streaming and leveraging standards like CMCD v2 and CMSD for precise large-scale synchronization. So go ahead, Nicolás.
Thank you. Let's start sharing screen. Here it is. And before starting, of course, I need to put the ad of the summer camp. So this year we are starting, just for the recording, we're starting the new edition of the summer camp this January. So everyone is welcome. And here's the video that we created for you. So here you are. I think it's very exciting to see the video, all the people and all the projects together. So if you want to know more about summer camp and want to escape from winter, just contact us and we will give you all the information you need besides what you already can find over there. So great. So after this ad, it should be I should do a talk about server side insertion or something like that too. To have this kind of, oh, not again, not again. Here it is, yeah, main content. So great. Thank you, Christopher, for reaching to us. And yeah, let's talk about synchronizing a lot of players. This is an open source implementation using CMCD version 2 and CMSD. So I think it's pretty cool. We have already done some trials of proof of concept with this, and we're trying to find people who thinks this is a good problem to solve and wants to put it in bigger scale. So the story is like this. Not so long ago, the experience of watching TV was very different. So there was only one device, life was very simple, the signal reached everyone at the same time. So we together as community, we were able to shout the goals at the same time. That was great. So you go to the window with your neighbor, goal, and all that kind of stuff. But yeah, with streaming, those days are gone. You try to just, close the windows, put your your hands in your ears, and try just to watch the match and shout the goals whenever you watch them, and not try to, get the spoiler from your neighbors. And so the idea is trying to bring those days back because of multiple reasons. One is that reason. What happens if we try to synchronize? It could be a neighborhood, or it could be a country, or it could be maybe it's just you're in a bar and you are watching in different TVs the same game, and there is some latency differences between the same content on the bar. So people who is in the tables are watching different time of the content and things like that. So we need to fix that issue for the viewers, and we have some idea to prototype and to do things with this. So again, the technical objective of this is to try to achieve frame level, or at least sub-second synchronization in a scalable way for thousands or millions of viewers. So the challenge we have is that right now we have multiple formats, main contents, main formats right now, HLS dash, or it could be low latency dash, low latency HLS, or L3D dash, all the low delay, low latency dash, new thing that Alex Giladi is talking a lot. So again, different formats, multiple players, players may have different buffers because the ABR algorithm decided something different, or just because the implementation of Shaco Player and Dash.js is just simply different and takes different approaches to the buffer targets. So yeah, that could be something that it's complicated. So the basic ingredients we need to achieve or to try to achieve synchronization will be, hey, we will need for sure a common clock because we want everyone to be at the same time trying to watch the same frames. So we will need a reference clock across all viewers. We will need, of course, a target latency. Maybe it's not this precise latency, but again, it's target because, again, network conditions may vary, and maybe the player is trying to do the best because it's not getting, I don't know, maybe even the lowest rendition maybe is having issues. So yeah, we will know that it's not going to be perfect for everyone, but at least we want to try to achieve that. And of course, a way to exchange the information about what's the synchronization we want right now and the current status of all players. So topics we're going to cover today. First, tiny recap of how timing information works in HLS and Dash, because maybe if you're not very involved in how those standards work, yeah, we need to understand how timing it's embedded into those formats. Also, how to prepare the content for synchronization, how to exchange the timing information with the players, how to synchronize a session in a player, and demo time, of course, and we will play together with that. Let's see if it works. And of course, we will going to wrap up with some future work we are thinking, or also trying to get feedback from you. So recap how timing information works in HLS and Dash. So let's start with HLS. You know that by default here we have right here, I think if I do this, you can see it. Yep, awesome. We have a playlist over there. It's not the multivariant. So we already have a playlist of all the different segments the player will need to play. So by default in HLS, with live content, we don't need a clock to make it work. We just, like this, we just define the segments and the duration of each segment, and the player it's going to, depend on configuration, going to take the latest segments and play from there. So you don't care if it's like today or in the future. It doesn't matter the timing. It's just, okay, I'm going to pick the latest segment, I'm done. So I don't care, the player doesn't care about timing here. Also, oh, now that I changed the button, it's like with this one. Also, in HLS, if you want to have some timing information in the playlist, there is a special tag that is the X program date time. Maybe you have worked with this, maybe not, but the idea is that this is just a simple tag that provides an absolute timestamp. Like here, as you can see, we have added, for example, before a new segment starts, we can say, hey, at this moment in the content, after you just finished playing these 2.001 seconds of this segment, the time right now is this one. It's like, I don't know, 2014 and whatever. It could be any time you want, in fact, because it could be also, this could be also work for, I don't know, if you want add some metadata about what happened with the show and you have recorded it, it's okay. And for example, hey, at this moment I want to show a banner, an ad, or do some custom stuff. You can use like this information to do that. So in fact, it doesn't matter if the clock is real right now. It's just a reference of at this moment in the content, this was the time, or this is the time that the player can do something with it. So again, basically, you can put there and you can put an absolute timestamp about the timing. Generally, this is added at packaging time. So the packager puts the information when generating the playlist. Or again, it could be, you can put any time in the past or whatever information you need to put there. And of course, this is an optional tag. So if you don't want to use it, just don't use it. live streaming is going to work anyway. Something that also, if you want to make some question or whatever, you can do it. Just raise your hand or whatever, and we can talk while we are doing the presentation. I don't care to just stop and do it more live if you want.
Is some packages can extract the program date time from timestamps in the source as well. So is it typically the time it got packaged or the time it got produced if it was coming from like an SDI signal?
Yeah, that's very, very interesting question. So I think it will depend in the end and use case you want to achieve. Again, as this time is just a clock to that it's going to be a reference to do something else probably with the player. Maybe it's just to put a score or something, saying, oh, look, this is our recording, and the match at this time, the score was Uruguay was winning 1-0 Argentina, because of course Uruguay always win. But but again, it's like depends on the use case you want to use with this. So for example, yes, if you want to put a reference clock for to know the glass to glass latency, for example, that's a very use case. Like, oh, the clock from the SDI signal, something like that. But maybe it's not the use case and you want to do other things. It could even be like, it could be, I know, epoch. You could start with epoch time and you can do something also with that. It will work. So the idea is that you can use this tag for the real purpose you want. So it could be extracting the real time from to know glass to glass, or just the packaging time, and you put the clock in. It's going to work anyway. Again, depends. The thing with this tag is what you're going to do with this information, and not what is the correct information you want. You know, it depends on the use case. I don't know if that makes sense to you.
Yeah, makes sense.
Awesome. So great. Let's now move to wrong tab. Next one. Oh, here it is. So again, use cases for this, as I was saying, it could be synchronized the play with external events or data, whatever, or to pick also, like if it was recorded, you can go to the, if you put the wall clock time, the real wall clock time. Oh, I want to see what happened with Opera at 5 o'clock. You can go there and do things like that. So the concept with this is, okay, this is the way we are going to put some timing information in the playlist. So we are needed to, we need this information. We are going to use this tag for our purpose of synchronizing players. So great, let's now move to Dash, how timing works in Dash. And this is very different and very interesting. Just for simplification, we are going to, I don't know if you're familiar with Dash, you have different ways to express how to fetch, how to build the URL of a segment. We are going to work with segment templates because it's the most used way for live streaming, and just to pick one of those. The thing with here is that we have a segment template, and there is a template that we say, hey, we want to the player. Imagine you just fetch the MPD, and you will have this. Okay, I need to fetch this 1/number. But the thing is how I build that number. And let's take a look at this. This is very interesting. So the first idea is in the MPD, you can define the UTC timing information. So here, I'm going to say the player, hey, the timing information, you're going to be able to know to get the clock from this URL. It's time.akamai.com/ISO in milliseconds. So the player is going to make a get and receive the time right now from this server. Then what we're going to do is calculate we have this value here that is a availability start time, that is since when the content is available in theory. But you can put whatever you want. You can see here, this is 1970, 1st of January, 0. So this is epoch. in Unix timestamp. So it's 0 in epoch. So we are seeing, okay, now we have the clock, this clock, and we also can now can calculate how much time since the availability time has passed. In this case, will be like the current time we got from the server minus the availability the start time. In this case, it will be if you think this in Unix timestamps, this will be the Unix timestamps of right now minus 0, because again, in this case, this is epoch. Epoch is 0. So great. The next step in our recipe will be to calculate the segment duration. The MPD tells this information by this. It says that in the segment template, it says, okay, the duration is this one, and the time scale is this one. So basically, to get the segment duration is duration divided the time scale. And if everything goes well, next slide, we have also the start number. That it's the idea is the calculation will be with this we're going to get the segment number that we want to achieve. That is the floor, so rounded to the closest integer number, the lowest integer number of the elapsed time that we calculated here, divided the segment duration that we got here, plus the start number we have here. And with that, we are going to calculate this number. In this example, as I was saying, this is the availability start time is 0. The current UTC time, imagine you just make a request, and right now it's like this time in Unix timestamps. Then the duration here is this number, so segment duration is 2, divided these two numbers. The start number is 0. So if we can calculate the final number doing the simple formula we just did, and then we got this number. Then the player will know, okay, now I need to watch this content. I need to make this get for this segment, and that's the way the packager creates the segment, and of course the way the player will request for those. So the idea in this at the end is that in Dash by design, when we are using, of course, segment templates, each segment has a time reference, because we by design we need some time synchronization to know what time is right now and which is the segment we need to get. A difference, in HLS it will be just fetch the playlist, and you are going to play the latest segments. And in this case, okay, with this segment template, you don't need to do any fetching or continuous fetching every X amount of time to get the new segments. You just need to calculate which is the segment that should be right now available for the player. So this is very cool. I don't know if you have some questions regarding this, but these are like the key concepts that we need to understand how timing works for HLS and Dash. So moving on, the things we need now to prepare the content for synchronization is, now if we understand how HLS and Dash timing information works, the things that we are going to need is we can work with this manifest and say, okay, we also need to package both HLS and Dash with the same clock reference. And if we understand that we are going to create the segments with in the playlist, we are going to put for each segment, like the calculation for Dash and the tag in the HLS playlist will be like the same. Then we are going to be able to, given a time, both HLS or Dash are going to say, okay, this is the segment I need to receive. So this information will be needed to create the synchronization. And the thing is that probably we are going to package both content with the same packager. because the packet will have again the same reference clock for both. So great. Moving on, we are going to need to exchange timing information with the players, and this is where we are introducing this concept of using CMCD version 2 and CMSD. So let's try to begin a little bit in the new concepts about CMCD version 2 and also CMSD. You may know that CMCD version 1, it's a way the player sends information to the CDN about the playback, the player status, and also like some metrics like the throughput and information like that. And in CMCD version 1, the player can send that information in query params every time it does a get to the CDN, or by sending also in headers. But in CMCD version 2, we are adding new modes that CMCD can be sent not just to the CDN, also to different third-party servers. We are creating new modes that are called the response mode and the event mode. So basically, I think I have it here. Yes, I have it here. So what are these new modes? In the request mode that we are calling CMCD version 2 is in fact CMCD version 1. It's the way the players send information to the CDN about how it's performing the network and everything else. Response mode, as you can see here in this diagram, the idea is after we do a get to the CDN and we have the response from the CDN, this is where response the name response, we're going to send the CMCD information that we already sent to the CDN plus the insights of, for example, the time to first byte, the time to last byte, and the response code we got from the CDN at this point, but to a third-party analytics server. So this is great because we're going to be able to collect. Imagine you have a multi-CDN infrastructure, whatever. We are going to be able to have a single point to collect all the data you want for that. And the last one is the event mode, as the event keyword here says. The idea is we are going to trigger to send CMCD information to a third-party analytics server every time there is an event in the player. An event could be the player started to play, the user paused the content, or there was an error. And also, we have a special event type that is a clock. So you can just say, oh, every 30 seconds, I want my player to send a heartbeat to my analytics server, just to know that, yeah, the user is still there. So I think this is the biggest addition in CMCD version 2, that we are not only going to send CMCD information to the CDN, we are now also be able to send to a third-party analytics server. And these modes can work together, like 3 at the same time, or even you can have multiple targets. Like you can send to 3 analytics server the same information you want. That's a super cool stuff that you can, again, have multiple servers collecting data. For example, maybe some servers are just collecting data for CDN performance, and other servers could be just collecting data to understand user behavior. And this is something very cool, and maybe we can cover this in another presentation to go deep inside of all these modes. But the main idea here is that with CMCD version 2, and I want you to take this into account, is that we are able to send to another server. It could be an analytics server, or could be whatever server that understands CMCD. So going back here, with CMCD version 2, we have a way to send information to a server, and we could. And the fun thing is that if we also use CMSD, CMSD is a way the CDN, for example, can send information back to the player into, it could be some keys, like, for example, I want you to select this particular bit rate or something like that. And that information is sent into the headers of the response of the CDN. But if you just abstract the idea, any server can send the CMSD keys. Just for I forgot to mention that CMCD means Common Media Client data, and CMSD is Common Media Server data. So again, it's a way to communicate some common keys, some common information through headers, this one, back to the player. But again, it could be the CDN. And now that we have CMCD being able to send information to a third-party analytics server, also that analytics server can respond with CMSD information. And another very interesting thing about CMCD and CMSD is that both supports custom keys. So you can say this player, for example, in the CMCD and CMSD specs, you will have a list of which available keys the players have built by default because it's in the spec. But also you as a developer can build whatever you want on top of that and say, okay, this is my custom key to send whatever information you want to send. So you can send information on top of CMCD from the player to the server, and you can send back information, custom information you want from the server to the CDN using these both standards. And I think that's a very powerful concept here. So moving on, this way, at the end, is a common pattern that we can use in anything. So we can, if we can send information through CMCD to any server, we can also communicate back any information we want with CMSD back to the player to do something with that. And this could be useful for content steering. It could be useful for, I don't know, lowering the bit rate of your players. It could be useful for whatever reason, because again, it's like we're starting to have very well-defined interfaces between a player and a server to exchange whatever playback-related data you need to exchange. And that's, I think that is super cool. So moving forward with this is that in CMCD version 2, there is a particular new key that is very useful for this use case, is that we can send the playhead time. And in the definition we have put in the spec that for live streams, it must be expressed as milliseconds times unique epoch. If you remember what we have seen in the previous, when we talk about how to put timing into HLS and Dash, we already talked about this. So we are talking about epoch information that we can put the, absolute timestamps that we can understand in Dash and also in HLS. So any content that already has that, it's very simple to send this key to say, okay, the time head, the playhead right now in absolute timestamp is this one. And again, CMSD supports custom keys. So for example, we can invent like com.example/my-key. And so we can also invent, and we just created for this one, 2 custom keys that we call com.sbta/clock. And this is a way we can send, for example, clock information from a server to a player. This could be another way to exchange clock information. And also we can set for example, send the player back some information like, hey, I want this target latency. This key, there is no CMSD key right now in the spec for latency targets. But again, we are just building our own, and maybe we will try to put it in the spec for CMSD version 2. So in this way, what we can build on the final diagram of what we want to achieve is we have a source, we have a encoder, whatever, we're going to have a packager, and we are going to have a reference clock here. The reference clock is going to be with how we package with the X program date time. Also, using the segment templates, we're going to create the segments with the same reference clock. And also, we're going to put a synchronization server. So the player is going to send CMCD version 2 information with the playhead information we just saw. And this server is going to process that information. It could be whatever business logic you want here. And the server, after the player did the CMCD version 2 request, is going to send back some CMSD custom keys about the clock right now and the latency about that it's references to this clock. And this way, we are going to have the timing exchange and the latency setup we want for the content. So moving on, any questions you may have here? Just making a pause if you want to ask something, or I want to understand if this concept is clear. And also drink a mate because Uruguayans love mate. So great. Yeah.
The next part you're going to talk about how the sync server works, right?
Yeah.
But okay. Yeah.
So let's go with this. So the idea is now we are going to try to achieve a basic. Again, it may be a different implementation for this, because something we wanted to just achieve is how to exchange the information, and then we're going to talk about what the player needs to do with this information. But the logic you want to achieve here could be different. For example, we could say, okay, I'm receiving CMC information from a player, and I can understand maybe that it's from, I don't know, the player is in Uruguay. And I can have all the playhead information about all the players in Uruguay. And I can say, okay, this is how the network, or it could be, I don't know, the city, Montevideo. This is how Montevideo is doing right now. So you can have any logic you want to achieve here to say, okay, for Montevideo, I want to achieve this latency because I have all this information for the players about the buffer, about the throughput they're having right now. So you can calculate whatever latency you want there. Or, for example, let's imagine another use case. You have a bar, or you want to just try to synchronize players that are making requests from the same IP. So you might think from the same IP, okay, maybe there is like in the same home, same bar, or whatever, because all the connected TVs or devices with the same IP, okay, maybe it's in the same home. So I can say, okay, for the players that I'm having with the same IP, I'm going to get the playhead time right now. I'm going to see the buffer, and I'm going to say, okay, this should be an achievable latency for all those players, and I'm going to send back just for the players that are reporting under the same IP a particular latency, just to again synchronize all the TVs in a bar. So the logic you can put here, it could be different, and it could be fun to. In fact, we're trying to play with different use cases with this. It could be synchronize a neighborhood, synchronize a city, or synchronize different homes. And that could be possible because this is just a way to exchange the information. So moving forward, the basic algorithm for synchronization with the player, it's pretty simple, and it's been, this is in fact what low latency HLS or low latency Dash does actually, to try to do similar things with this. So what they do is sync with a reference clock. So you have the clock information, right? That it's coming from the HLS playlist, or it's coming with the Dash information. Then you need a clock to say, okay, what is the time right now? It could be your computer's clock that probably is going to have different, it could have different values in different setups, because I don't know, maybe you just didn't press the synchronize clock option in settings in Windows, or you are an old TV and for some reason, I don't know, it's not synchronized. So we need to have a reference clock. We know we need a latency that is, of course, references to this clock, saying, okay, if this is 5 o'clock, I want to be 6 seconds behind the reference clock. So then you have then you can calculate what is the time you need to be playing right now. And then the player is going to modify the playback rate to achieve the target latency. So basically, if we are ahead of the timing, we should be this. If we are behind the time, we are going to play a little bit faster the video. So it could be 1.1x, or it could be bigger or smaller than that. Generally, the user doesn't see as much the difference when you make those tiny variations in the playback rate. Or if you need to decrease the latency, you need to go back in time. It's not going back in time. The thing is that we are going to play the video more slowly, just to catch up with the latency we want. This works. This works very well in HLS in browsers. Sometimes it doesn't work very well in TVs or things like that. Or let's say that doesn't work very well. Let's say that doesn't work well with all the options of playback rate. Sometimes it works very well with I don't know, some values that I don't know, that are supported. Again, this is an issue with playing with TVs. Like, not any time of playback rate will work, but some playback rates are going to work. And that's a funny thing that we can cover in another talk. And again, if we cannot achieve the latency, maybe we should say, okay, I'm dropping, because again, imagine the situation when I want the player to be 2 seconds behind the reference clock, but my buffer is not going well and whatever. So, okay, the player should be able to decide, I'm not going to follow this latency. I'm just going to throw this and do the best I can, because I don't want to have a rebuffering issue. I don't want to have buffer starvation situations. And at the end, the player is the one who decides what's the best for the user. And with this, we're just trying to tell the player, I would like you to be in this latency target, try to achieve it, and if you can't, do the best you can. So yeah, the end decision is in the player. So again, it's like this. We have the playhead time here. This is the reference clock. Imagine this is a timeline. And this is the target latency we are sending, like, I know, 6 seconds. And this is right now, like the clock, 5 o'clock. So if we have this situation, we are just going to set the playback rate to 1.1. And if we are in the other situation, that this is the latency we want to achieve, and the playhead is here, so we're just going to play 0.9. It's not that we are going to get back in time, it's that the time is going to be to catch us. Like, the time is going to catch the player. So that's the fun thing. And this is the idea of what we have built. Also, it's very scalable because this is a microservice. So you can deploy this. The amount of something very interesting is this is in CMCD version 2. Again, you can send, for example, the keep alive, that we talk about event. So you can send, it's not that you're going to send every time you have some segment or whatever, is that you can send this information every 10 seconds and send back the information on when you want to, what this latency you want the player to achieve. And every 10 seconds, for example, you're just telling the player if it should change the latency target or not. And this is we have built like a microservice for this, just to calculate, to send back the information of the latency we want. Is a fixed one that we can set up, and I will show you right ahead. So this kind of scaled very easily with the amount of players you have. Yeah, sorry.
Has anyone talked about feeding that information from the sync server further back to like the encoder, to like changing bit rates, changing cop lengths? Like, I guess the segment duration, presumably, I think it has to be fixed based on the manifest level. But like, if you're servicing an area, I guess you're going to only have one distribution encode, but based like thinking of like multi-region AWS encodes from like a single source that you're like sending to like 3 different regions. Could you, based on the CMCD and CMSD information, dynamically update your encode to try to accommodate latency targets?
That's that's very interesting. No, we haven't talked about that, like changing encoder parameters, but I'm sure that's something we can do it, because again,
Yeah.
we have the information. So even
Yeah. Okay.
if we have some logic that we understand that if we receive this from the players, maybe we should be able to change something to have a better user experience. That sounds very good. In fact, maybe we can talk after this. There is a proposal about how to send BMAF information from here, from encoder packager, up to the player about all the in all layers. You put the in all segments. You put the average BMAF of the segment, and you can collect what is real, what is the player actually playing, because you create the ladders of different BMAF ladders, but sometimes to make the mix between the bitrate ladder and the real BMAF, it's like, oh, I had to understand what the encoder did. I had that database here and that, but just to report it back like this way, and you can make decisions about the beam, like the real BMAF the users are experiencing. So I think it could be something related with that, and it's fun.
So,
but again, it's not for synchronization in players. It could be for bitrate optimization or ladder optimization, or I don't know, things like that.
I know earlier in the talk you're mentioning the ABR logic. Is it meant that the sync server would replace the ABR logic in the player, or at least you could force you could update ABR logic instead of deploying new HTML pages? You could have the sync server drive the ABR logic that way?
Yeah, that's the In fact, maybe we don't need a sync server either, but in this way you exchange information between a server and the player. We can send like CMSD information to say, I want you to be in this ladder because of, I don't know, I need more. I know maybe I'm doing a fast channel, so I don't expect everyone to have the best resolution. I want to have more users because more users means more ads means more money. So maybe if you're running a fast channel, you prefer low, not as the best resolution for each user. You want more users for the same amount of bandwidth. So you can have that kind of controls with this, and that could be super interesting use cases to make again this information exchange. And again, if there is, maybe you have another question, or if not, we can move on to the demo. So this is an open source repo. You can download it and run it by your own. Let me find the links here. So and I need to change window. I want to share all my screen right now. This is my screen. So I'm going to give you in the chat, let's see if it works, 2 links. Oh, these are the 2 links. You can play with Shaka player or Dash.js player. It works with both. And I'm going to open, just in case, the Dash one here to show you what you're going to do. And this tiny web that this is the, oops, sorry. That's what. This is the server. So if you just press one of the videos, you're probably watching something like this. Just the thing I want to ask you is not leave the tab in background, because when the tab is in background, the latency, the player is not going to achieve the latency we want. It will just drift away. That's the only thing I need to change the demo for the next presentation I will do about this. Every time you find a new use case too. So what you have here, what you are watching in your player is, this is, depends if you choose Shaka player or Dash yes. You have the player here. This is just a video playing over here. This is the client time of your computer. This is the information of synchronization information we are sending back. This play is making CMCD requests to this server. You can inspect and see in the network tab this an endpoint that says CMCD/something. This is not the CDN. This is just an endpoint that has this tiny server synchronization server, all the CMC information, and in this CMC information you will see, for example, that we have here the PT, that is the playhead time. And in the response, we can see if this works well. Request, response headers. Yeah, response headers. You can see that we have a header that is the CMSD dynamic. And here we have the custom keys we were talking about. The server, after the client make this request with CMCD information, the server say, okay, I want to achieve this. This is the time right now. I want you take for reference. And this is the latency I want you to achieve. 12 seconds behind this timestamp. We are also playing with different targets, like try to achieve one of those, but this doesn't matter. Right now, we are just working with this is the latency we want the player to achieve, and this is the time for reference in this particular case. So here you see, again, the client time, let me just put a bigger, just in case. The synchronization time after we receive this clock, what is the clock the server is telling me? The offset, this is just the offset between my time and the reference clock that the server is giving to me. This is in milliseconds, so it's just -1 millisecond, 5 milliseconds. We are updating this drift every time we make a request. This is the playhead time that we are getting from the player, because we are, in HLS, because we are taking the tag, or in Dash, we are just making, getting how the segments are built. This is the playhead time, but in unique timestamp. This is the seconds behind live between the clock, this reference clock, and the target latency we are configuring, we are seeing right now. Also, we are putting a chart here when you can see the delay. The live delay is now 12 seconds regarding against the reference clock. This is the buffer level that the player has right now in seconds. And here you have the playback rate the player is playing right now. So in the server here, some of you may be having in background or whatever, but it doesn't matter. In theory, I have all the sessions, all the reports from everyone here. And you can see here in my example that the idea is that now that we are in the server, we are sending back to every request to be 12 seconds behind real time, or behind the reference clock. Now I'm going to say, oh no, I want the players to be at 6 seconds. I update the latency. The player is making the requests and receive, oh, I need to be at 6. So it increases the playback rate to 2. 2 is very aggressive, but it's just a showcase. Now we can see how the live latency decreases because we are playing more quickly than real time. Of course, my buffer is getting lower because now I have less space for for buffer, and we achieve in some seconds we achieve the 6 seconds latency we wanted. We have some players here that are maybe in background or something or not working very well, but maybe you can see that I want to fix this for the next demo. Oh, someone just got back from the from background, and we're going to see how it's decreasing every time. We can see also a tiny gap here, but the idea is like that. The player is making CMCD requests, and we are sending back the information of what we want, and the player is being able to play with the buffer and playback rate to achieve the latency we want. And now we're just going back to, I don't know, 8 seconds update latency. And now we're going to see again how the delay is increasing. So let's go back to the presentation now that I have just 1 minute left.
Is the time it takes, like the playback rate, is that you're just being as aggressive as possible to get to the buffer length?
Yeah, I'm just trying to be very aggressive with that.
Yeah. So like in reality, like if you did it at like 0.11 or 1.1 or 0.9, then it'll take like several seconds for
Exactly. Yes.
Yeah. Okay.
Exactly. That's the idea. That's the idea.
Yeah.
This for demo purposes, we are not going to spend a lot of time. So it's better to see, oh, it increases. So whoop, you're achieving the latency. Even you need maybe some like thresholds, things like that to say, oh, I try to achieve, or if you are very far from this, maybe you can do something different. So going back to presentation, just to try to finish in time, the future work with this is try to play with ladders. What happens if a player cannot achieve? But maybe we can say, oh, try to achieve in latency. These are the latency buckets we want to achieve. We need to play around with better logic for buffer starvation. We are just being very naive with the implementation right now. And in the server, we can play better with the information from the players. To right now, the example, I'm just putting the latency I want, but we can play with the info. We can have better decisions with the information we got from the players, because we know the buffer they have, we know the bit rate they have, we know where they're located, if IP or the IP of the user, if the city or whatever. So right now it's very naive. It's just send the same latency for everyone, but the idea was just to showcase how the mechanism, how the information exchange could be, and not we didn't want to be in a particular implementation of how to do it or how to decide the latency, just to how to exchange the information. And this is a project very fun that we make with Alex Gilari. You may know him, Emil from Juarez, Juan Manuel, Constanza, Sebastian. So big thanks to all the guys, because it was very fun to play and with this kind of things. And again, if you have any questions, I know we are just in time, but the idea was to make it as interactive as we can, but maybe you have any other ideas or questions, whatever. Yeah, go for it.
Manny?
Hey, Nicholas, thank you for the amazing presentation. I don't know, like, if this is a good question to ask. Like, so instead of like changing the playback rate, why don't we change the buffer? I get that the buffer will be limited by the bandwidth and the bit rate, but like, why don't we focus on changing how fast it is buffering instead of just the play rate itself?
Yeah, that's a good question. But at the end, I can change, for example, my buffer target, because right now, if you remember, maybe you have, I don't know, 12 seconds, and so my buffer target is try to fill the most you can of those 12 seconds. But the thing is, if I just have less buffer, even the playhead will be like far ahead. So it's not just how much buffer I have, it's how fast I consume that buffer. Because at the end, you can think of buffer, if you think of buffer in bytes, yeah, that's the thing. But if you think of the buffer as seconds of video, I need to consume that faster or slower if I need to play with the where are you in time. It's not just how much amount of buffer, is how fast I consume the buffer. I think that's the key over there. So I think it's not enough just to play with the level of buffer, is to play of how you consume the buffer. I don't know if it makes sense to you.
Yep, that makes sense. Thank you for the answer.
Thank you. And also, if you want to implement this in production for a prototype or whatever, I'm super happy. Any other ideas,
other
questions, whatever?
Okay.
Great.
Well, thank you, Nicholas. Sorry for going over a little bit, but this is actually pretty interesting, and the demo worked flawlessly. So that's always good when demos work. So,
of course, I will fix the other issue, and that will be a better demo. But that's the part of the demos.
yeah. No, that's good. All right. So thank you, everyone. If you know anyone who wants to do a talk about anything video related, we still looking for monthly speakers, and otherwise, hopefully have someone lined up for August, and then we'll see what happens. So cheers, everyone.
Thank
Great.
you.
Yeah.
Thank you.
Thank you for watching. Thank you.
Thank you. Bye-bye.
Bye-bye.